welcome to all. Myself Dr. Neha Desai, Assistant Professor in Department of Chemistry, RBNB College, Srirampur. Today we will start a new subtopic from CHA 392, that is size exclusion chromatography. In size exclusion chromatography, what is the syllabus that we want to cover? The first one is the principle. Second one is the calibration chromatogram. Then the third one is the molecular mass determination by size exclusion. Then fourth one is the phase system. And fifth one is the applications. So these are the points that we want to cover under size exclusion chromatography. So to begin with, the first thing is the principle. So size exclusion chromatography, it is basically considered as an entirely different technique from all other chromatographic methods. So this size exclusion chromatography technique, it is based on the two factors. The first one is you have to consider the molecular weight, and the second one that you have to consider the size of a molecule. So these two are considered as the base for size exclusion chromatography. Here, in case of size exclusion chromatography, you have to not consider the interactions between the stationary phase or mobile phase. There is no attractive forces or repulsive forces in between the size exclusion chromatography. Basically, the separation of a components from a column is based on their size and the molecular weight. So this technique is considered as the different technique from all other chromatographic methods. So in case of size exclusion chromatography technique, it is most commonly used for the analysis of the polymers. The size exclusion chromatography, it is also known as the molecular sieve technique or molecular sieve chromatography. So the another name for size exclusion chromatography is molecular sieve chromatography. So in this case, what is the main characteristic feature of size exclusion chromatography is the use of porous column. So in case of size exclusion chromatography, we are using a porous column. So the porous material is used for the column packing, and depending on the size of a pore, the separation of a components into the different things, takes place in case of size exclusion chromatography. So for that purpose, in case of size exclusion chromatography, we have to consider the two factors. One is the radius of the molecule and another one is the radius of the pore. If the radius of the molecule it is higher than the radius of a pore, then it is not accessible and it is separated at first. So the molecules which you want to separate by using the size exclusion chromatography, they should be small enough so that they can pass through the different pores. So only thing that we have to consider here is the molecular weight, then size of the molecule, then along with that the mobile phase of a material. Mobile phase is only responsible to carry out the components to the different things. So in this case, that is the molecular sieve chromatography, we have to consider the molecular weight and the size of a molecule, and at the same time we have to consider the pore volume or a pore diameter. So when you want to analyze any substance by using the molecular sieve chromatography, then the size of a molecule should be as small as possible, because what is the sequence? If the size of a molecule is small one, then if the size of a molecule is medium one, and lastly if the size of a molecule is large one. Then when the size of a molecule is small one, then it is separated at last. Then if the size of a molecule is medium one, then it is separated at the middle. And if the size of a molecule is large one, then it is separated out at first. So this is the sequence for size exclusion chromatography. So what is the case? That is the size of a molecule, it should be as small as possible so that it can pass through the pore volume and it is accessible, and a well separated chromatogram will be observed at the end. Then if the size of a molecule is medium one, then it will be separated at the middle. But if the size of a molecule is very large, then the pore volume is not accessible and it will be separated out at first. So if you consider the elution time, then the time required for the separation or the last peak which is observed in the detector signal, this time is mainly known as the breakthrough time. So this time it is known as the breakthrough time, and here when you pass the sample, then the smallest molecule it will be separated out at last. So the time taken or the last sample to be appear in the detector, so the time required for it, it is known as breakthrough time, and it is the largest one for the having the smallest size molecule. And depending on their molecular size, all these different types of samples, they are excluded by using the size exclusion chromatography. Now the next is these substances which are detected at the last, these are known as the breakthrough time for the all other column chromatographic methods. Here your solvent system or your mobile phase, it will not interact with the stationary phase, or there is no interaction between your material and the stationary phase. As there is no any attractive forces, repulsive forces, or there is no any interaction between the stationary phase and the mobile phase, this size exclusion chromatography technique is considered as the different technique from all other liquid chromatographic techniques. So here, if you compare the elution process, then in case of size exclusion chromatography, the smaller molecules, they are eluted at last, then the middle molecule, they are eluted in the middle one, and the large size molecule, they are eluted at first. So for considering the elution system, we have to consider the pore diameter, that is the molecules, they should pass through the pore diameter or a pore volume. So the accessible pore volume, it is represented as accessible pore volume is equal to R pore minus R molecule all these raised to square into pi into L minus R of a molecule. So this is about the accessible pore volume. Accessible pore volume, it is nothing but the statistical mean of a radius, which is represented by the R1, which can remain in the large pore volume, and the substance which is having a larger radius, it is known as the R2. So there is one relationship between the radius of a molecule and radius of a pore. Depending on that, you can check the accessibility, or you can determine the elution time required in the size exclusion chromatography. If R of a molecule, it is greater than R of a pore, then no pore volume is accessible. So it will be separated at first, and you will observe the first peak. Then the second case, if R of the molecule is less than the R of a pore, then available pore volume is a function of molecular radius. So the separation is taking place according to the molecular size. And the third one, if the radius of a molecule is very less than the radius of a pore, then all the pores are available. And as a result of this, you will observe a final peak. Okay, so this is the sequence for size exclusion chromatography. That is, radius of a molecule is greater than the radius of a pore, then no pore volume is accessible. If the radius of a molecule is less than the radius of a pore, then available pore volume is a function of a radius, and if a radius of a molecule is far less than the radius of a pore, then the all pores are available. So here the radius of a molecule, radius of a pore, and the molecular size of a substance, these three are the key functions in case of size exclusion chromatography. So after considering this accessible pore volume conditions, what are the things that can be summed up in case of size exclusion chromatography? They are as follows. First is all eluted molecules. All injected molecules are eluted. Then the second thing is the breakthrough time it represents the completion of a chromatogram. Then the third is the elution volume or elution time is a function of molecular size alone. Then all the separations, they can be carried out completely after a small amount of mobile phase is passed through the peak capacity. Moreover, apart from this, there should be at least a 10% difference in the molar mass of the two components if you want to separate them or analyze them by using the size exclusion chromatography. So the next thing is that there should be at least a 10% difference in mass of the component to be separated by using the size exclusion chromatography. And one more important thing is that here the peak broadening does not take place with the increase in the retention time. In contrast to the all other methods, molecules are prompted to reside in the stagnant mobile phase, hence the plate numbers are generally lower than the normal HPLC. So all these are the key points by which the size exclusion chromatography can be summed up. First one is the all injected molecules are eluted. The elution time, it is a function of the molecular size. The breakthrough time, it directly represents the development of a chromatogram. And size exclusion chromatography is most widely used for the molecular mass determination. Moreover, there is no interaction in between the stationary phase or a mobile phase, and these types of molecules can be separated when there is at least a 10% difference in the molar mass of the substance. And in contrast to all other methods, in the In this type of a chromatography, the number of theoretical plates are lower as compared to the any other technique. So this is about the principle of size exclusion chromatography.